Okay. So guys, if you don't mind, let me check one more time. So you can hear me, right?
Yes, sir.
Good, thank you. Yes, good to confirm. Okay, all right. So basically, I did a little bit of homework myself to see you guys' question there. So I would suggest we run the Q&A session this way. Okay, I already went through all your questions over there on the Google Doc. If they are good questions actually, and some of them are somehow related to each other. To go over them more systematically, for those of you who actually ask me questions there, or for those of you who want to know my written response, you can take a look over here. I put Jackie's response over here. I just answered them briefly. So what I would do is I will try to address them in the order I think I should follow, and then I'll do that on my iPad. Okay, I might refer them to them as well, but we'll see how it goes. But if there's any question you want to interrupt me, please just go ahead. And I'll try to check the private message over here as often as I can, okay? So now let me switch to my iPad. Okay. The first question there is really about some part of the lecture notes. Let me just go to my iPad over here, okay? Oh, you know what? Before I talk about the Q&A, since many of you are here, let me just talk very quickly about some announcement quickly, okay? And then we'll get to the Q&A. So let me remind you very quickly, your lab number 1 has been released. You will be given 2 weeks to do it, including today, right? It was released earlier, much earlier today. And then I would suggest if you haven't really finished lab 0, even though the due date is September 24th, but you may want to finish your lab 0 as early as possible. That will definitely help you to complete lab 1. Okay, that's my advice. Okay, and then for lab number 1, the first scheduled lab session for you to ask TA questions will be on Wednesday. So before that, to really get the most out of the TAs, you may want to read through the instructions about lab 1, and especially the background. So we're going to have you do some interesting data structure, which you may not have learned in 2011. So it might be a new challenge for you. But you can also at the same time to see how you can do both implementation and specification in the same lab. That's something we'd like you to achieve as a learning outcome. Okay, you're given some starter tests, and as I mentioned, I'll keep mentioning this. So treat the starter test that we gave to you like a precise documentation. In some way, you should really train yourself reading the test cases so you can know what the intended functionalities are for that for your features. Okay, if you have doubts about this, just speak to me or maybe ask me during the Q&A later. And in your lab manual, there's one section there called optional tutorials. So I also try to see if you want some extra help on understanding some basic or intermediate or advanced features, you can also consult with the tutorial video. It is optional, so you don't need to watch them if you're comfortable with just the written part of the instruction, okay? And then just to remind you, your quiz number 1 is actually due this week. It'll be 5 p.m. Eastern time, Friday, September 18th. At the same time, I'll also open your quiz for your lecture series number 2, right? I'll just go according to the calendar, okay? And then just to remind you quickly, for your scheduled labs on this coming Wednesday, it will be 10 a.m. and also 2:30 p.m. So I will send an announcement either later today or early tomorrow to tell you how you can speak to your TA, okay? So it will be sorted out, okay? And then today, once I finish my part, which maybe take about 30 minutes to 40 minutes, you can also ask me questions related to lab 0. That's absolutely fine, okay? Okay, that's about the quick announcement, okay? So let me just go over your question one by one, okay? Okay, so the first one really is about some confusion. You can also refer to the Google Doc. I'll just tell you the answer right away, okay? So now let me just go to my iPad right away, okay? So now let's say, so this is actually from your account version 2 of your lecture, okay? Account number 2, okay? Version number 2. And that one there is mainly to discuss for your approximate, the Java approximation of the precondition, right? So the one I was talking in the video was like this. I say amount is less than 0 over here, may not be a very complete error condition, like an exceptional condition, because let's say this. If, let's say this, sorry, not this one here. What I meant to say is this. Beg your pardon. This one here, that's what I meant to highlight. Okay, this one here. So let's say this, when you look at this particular condition over here as the error condition, that means it will be only considered as an error if the amount, if the balance is strictly less than amount, but what if the balance is exactly equal to it, right? So let's say, for example, let's say if your current balance is simply $100 and the amount of the withdrawal, let's say that's also equal to 100, okay? So you got 100, 100. So now 100 less than 100 is actually false, which means this will not be considered as an exceptional condition, so you can get by. But the consequence of this is you're going to deduce $100 from $100, which will give you 0 balance. And this one, according to our requirements, number 1, is considered as not acceptable because the balance should always be positive, right? So this is what I said in the lecture video. So I believe the confusion you guys have was like this. So because I didn't speak explicitly about this particular constructor, right? So if you look at the constructor for account version number 2, you can see I say balance should be, it will only be considered as an error if the balance is strictly less than 0. So your question was, what if the balance that I want to initialize over here is simply just 0? Shouldn't that be disallowed? I agree with you, yes. So to be, in this case, which I didn't mention in the lecture, the correct error condition over here should be less than or equal to 0, so as to disallow any initial balance to be 0. So we can still satisfy this particular requirements. It's just that for that particular lecture part, I was mainly trying to focus on the precondition or the error condition over here. That's why I didn't mention about the constructor. But I think you guys' observation is right. So to be correct, this part over here as the error condition, it should be less than or equal to 0 as a error condition, okay? So that's the first thing I would like to talk about quickly, okay? And then there's another terminology I want to talk to you early in the course. Later on, we'll revisit this concept again later, okay? When we talk about subcontracting. But I want to talk about the notion between weaker and also versus stronger precondition, okay? Especially for precondition, it might be easier to understand, okay? So let me just clarify this, okay? Let's say, again, let's talk about the withdrawal command. Let's say we consider 2 versions of the withdraw command. Let's say, let me draw the boundary between. Let's say we got withdraw version number 1. Withdraw number 1, so that's version number 1. Let's say we have an amount over here, assuming that it's simply declared to be integer, right? I'm just saving some writing over here. Now, if I say require over here, I require, let's say the amount over here is strictly less than the balance. Okay, so now, for example, if I got $100 in my account, I can only withdraw up to 99. I cannot withdraw 100, okay? So that's precondition number 1. So let me say this is called precondition number 1. It's a tag, okay? Let me give you another version over here so I can introduce my term. So if I say withdraw number 2, and then it's also going to take an amount also of type integer. And I'm going to say require over here, and now I'm going to give you P2 as the tag for the precondition, okay? So now let's say I want to be a little bit more tolerance, okay? So I'm going to say amount less than or equal to balance. Okay, so now you can see the P1 and P2. First of all, let's agree. P1 and P2, they are not equivalent to each other, okay? Now, I want to be more precise, and let me ask you this. If I want to say, is it possible to say one implies another, use implication, meaning that satisfying one should really imply the satisfaction of the other. How would you put it? So on the left-hand side, should you put P1 or P2 over here? So that's a question. Anyone want to answer in the chat? So over here, should I say, okay, how about this? Let me say, should I say P1 implies P2? Or should I say P2 implies P1? Okay, so I got option number 1 and option number 2. So which one? I can see Kevin is mentioning something about the superset of superset. That's good. Okay, I'm gonna get to the set idea in just a moment. Okay, so now the idea would be, should it be 1 or 2, right? Okay, okay, I have 1 over here. Okay, Ring and also Edgeman. Okay, you guys said 1. Actually, 1 seems to be correct. So what you're saying is, okay, one is actually correct. So we are saying that amount less than balance implies the other one, which is amount less than or equal to balance. Okay, so now if you can actually argue such logical relation using implication, so now you can say that on the antecedent side, we say that this is the stronger one, because satisfying the stronger one will mean that you can satisfy the weaker one, right? So this will be the weaker one. So whenever if I later give you the question about whether one predicate is stronger than or weaker than the other, you should always think about the predicate. Okay, let me draw some diagram to show you. Kevin also mentioned about something about set. Okay, let me say this. Let me try to be more explicit about over here. Let's say this one here is simply just green, right? Just let me change the color so you can see more easily. Let's say this is green. And let's say this one over here is blue. Okay, green and blue. The green one is actually stronger. So that means in terms of the set theory, it should correspond to a smaller set of satisfying values. So let me put it here. So the green one is going to be something like this. Okay, so now this really is represented by the amount is less than the balance. For example, let's just make one example here. If I say amount currently is simply just, let's say the balance is 100, right? So now, how many satisfying value do we have in this particular set, right? So that means we got amount might be 1, amount might be 2, amount might be 3, all the way to 99. But it does not include 100, right? Because it's strictly less than, okay? On the other hand, if you look at a weaker, the blue one, if you look at a weaker precondition over here, so that one there is actually a strictly larger set, okay? You can think about conceptually, it's like this, okay? There's a blue one, so this is a weaker one, so that will be amount less than or equal to balance. And now, to be more precise, the extra member in this case would be exactly the case where amount is equal to balance, okay? So now, why am I talking about this? I think whenever you talk about, especially for precondition, when you say one precondition is weaker than the other one, so what does that really mean? Let me write it down and then I'll explain. We should really revisit this idea for a few more times later, especially around the end of the term. We have to talk about program correctness, and we definitely need this. I just want to give you a little bit of warm up before that. So let me say this, weaker precondition has more satisfying input values than the stronger one. The stronger preconditions. Okay. So for example, you can see the you know what? Since I say weaker should be blue, so why don't I be consistent with the color here? So this one should be blue over here. So now you can see the weaker precondition, like in this particular case over here, it actually has more satisfying input value. For example, it allows this particular input where amount is equal to balance, right? Okay, so now, so that simply means the consequence of this is weaker precondition is more tolerance on the clients. So when I say I'm being more tolerant on the clients, which means whenever the client is trying to make the following routine call, let's say if the client simply say, I got account objects over here, if I say ACC dot withdraw, let's say withdraw number 1, and also ACC dot withdraw number 2. Okay, we know that withdraw number 1 is the stronger one. So let me put it in green. Okay, just again, be consistent here. This is the stronger one, so I'm putting in green. And this one here is actually a stronger one. Let me just make sure it's all blue. Okay. Okay, so now if I try to make these two feature call over here, ACC the withdrawal number 1 versus ACC the withdrawal number 2, right? This is withdrawal number 1, this is withdrawal number 2. So now, which one is being more tolerant, meaning that which one allows more value that can be passed by the clients? Apparently, it is the weaker one. So now, in this case, it will be this one here. So the weaker one will be just the this one here. So this one here allows the case when the amount is equal to the balance. So that's why it's more tolerant. Okay, what's the take-home message from this particular slide over here? So I'm just showing you this topic over here a little bit earlier than it should, but I just want to give you some early exposure just for the first time. So the take-home message from this is this. Whenever you're trying to design your precondition there, always think about, is my precondition being too weak? Meaning that, am I allowing any input values more than necessary? For example, if your current precondition is simply this one here, so you got to think about, should I really allow this particular input value to be called? If I shouldn't, and in that case, I should really make my precondition stronger. Okay, so I will later talk about stronger versus weaker, very often. Okay, so this one here just to give you some idea about a little bit logic over here. Okay, any question about this particular example here? I can talk about it. Okay. Okay, so now let me move on to the next one. Okay, so I think this one here, it seems to be also a very common confusion. According to the work document, I've seen more than one instance of this question over here. Okay. Okay, let me take a look question here. Maybe I should pause a little bit. I shouldn't go too fast. Okay, let me just take a look of the chat if you don't mind. Let me go last in, first out first. So Rain is asking, but what if the client wants to use all of the balance? Yeah, so according to Rain, she was really asking this. So we know that this particular precondition is actually stronger than this, logically speaking, right? Because we can prove this particular implication. So now the question is, which one should we use? Okay, which one should we use? I would say which one you use, either the stronger one or the weaker one, depends. It depends on what your requirement is. Well, according to our bank requirements, we should definitely use this one here, which is stronger. So that wouldn't give us any possibility of, let's say after the withdrawal, you will get a balance of 0. Okay, if that's our requirement. So I would say it really depends. So when later on, once you graduate from this course, whenever you design any artifacts, you always have to justify your design decision. So this is just one example. Okay, you have to see what's the requirements you want to satisfy, and then your design should go accordingly. So Usama actually got a question about the error in the virtual box. So I would say, Usama, how about either send me an email or we can talk maybe during my office hour so we can sort it out. Okay, so I think we try to prioritize the question related to lectures. Okay. Okay, so now, okay, let me see this. Okay, that's being answered already. Okay. Okay. So now let's move on. Okay. Okay, so this one here is really important. Let me tell you what the question was. So now there was one slide in the very beginning of your lecture series, your week 1's lecture. Okay, let me just talk about it quickly, right? So that's something about what is a good design. And then I said somewhere over there, I said, upon contract violation, there should be the fault of only one side, which means if there's anything that's wrong, you should blame either the supplier or the clients, but not both, right? That's what I said in the lecture. Let me read your colleague's question to you, and then we'll talk about it, okay? I do have some example to show you, okay? So the question goes like this, okay? So there should be exactly one violation of the contract by either supplier or client, yes? And that's better than having none or both violate the contracts, okay? He's not really understanding why. So why is it better than non-violating the contract, okay? So I would say this. So that's why I simply put a title over here. Does no contract violation really mean you're doing well? That's the question, right? So let's say you simply try to run your projects, let's say, and then you simply got no contract violation. Does that really mean you got 100% reliable software? Okay, that's the question. The answer in principle is no. Okay, it's very important for you to get that experience. Okay, let me just give you some simple example over here. Okay, let's say this. Let me just give you the general principle, and then we use one simple example to explain, and then we'll see more example later. Okay, and actually this question here also is connected to what you're going to learn in week number 2 about writing complete postcondition. Okay, let me just tell you the principle first. So here we say that given a faulty implementation, let's say if your implementation is simply just wrong, which means the supplier is doing something unexpectedly, okay? And then there's simply no contract violation, right? So now when we say no contract violation, we said that in general, it may not necessarily mean you're doing fine, because it could be that your contract is simply just incomplete, okay? So that's the point I'd like to make. So when you're running your software and then you simply find that there's no contract violation, you cannot just make the conclusion that all your code is working. Not necessarily. It could be that maybe the contract you have written is simply too weak in the sense that it allows all the input-output value. Let me just give you one extreme case right away. Okay. Let's say I have my binary search routine that I want to implement, right? So I got my array, my array arguments, and also I got some X to be searched. Let's say, okay. So now, if we can simply say in general, no contract violation simply means it is good. I can very easily satisfy this. I can simply say require true over here, and then whatever implementation it is from the supplier, and then over here ensure, I will also say true over here. Okay, it's guaranteed. Whenever you call this particular binary search, because the precondition is simply just true. So any array you give, sorted or not, will be acceptable. Any element you give, existing or not, will be acceptable. I think having this even, so this means even if A is unsorted, will be accepted by binary search. And we know very well, conceptually speaking, that the result for binary search on an unsorted array should be undefined, because it's simply just the assumption we're making, right? But if you simply have the precondition being true, so that means you wouldn't get any precondition violation. But not having it doesn't really mean everything's working well, right? That's point number 1. And point number 2, let's say the supplier does something over here which is unknown to us. Usually the implementation secret is hidden from the clients, right? It's really hidden from the supplier side. Okay, so let's say this: when the client signed a contract with the supplier, if they simply agree that true is the postcondition, so that means whatever that is produced by the supplier side, it will always be just evaluated to be true. So is this a really good contract? Is it really fair for the clients? Apparently it is not. So that means whatever the supplier does is simply just going to be acceptable. It's simply just true. So no postcondition will ever be violated at the runtime for this particular binary search, right? For example, let's say if the supplier does something very crazy, it simply just return, let's say -1 always. In that case, when we evaluate -1 on true, it will still be true because anything will be evaluated to true. So the main message over here is not having any contract violation doesn't really mean everything is going well, not necessarily. Let's see a more concrete example here. So this one here is just one extreme, okay? So that means since you're really trying to pick up the design by contract idea for this course, I would say whenever you see that your require is simply true, or your ensure is really true, make sure you have a good reason. But I would say typically, there might be some cases where you don't have any precondition, might be. For example, if you recall your lab number 0, the get detachable birthday query over there actually will always be acceptable for the input. The name can either be existing or not existing. In that case, you don't want to impose anything on the client. That's okay. However, for the case of the postcondition, I would say it's very odd if you don't have any postcondition, if you simply leave it empty. So that's not a good sign for your design. Okay, it's more like at a design level. Let's see a more concrete example over here. Okay, let's say I have a very simple routine, like a query for you to implement. Okay, let me highlight it here. It's called absolute value. given some integer, which may or may not be positive, right? That's why there's no precondition on the clients. The client can simply pass any arbitrary integer, okay? Could be negative, can be 0, can be positive. And then it's going to return, as a result, integer, okay? For now, let's just forget about the implementation for the moment, okay? It can be anything. It could be something that's correct, or it can be something that's very bad, okay? I want you to consider this particular post condition over here. Let's say that's all we got, okay? Of course, the implies is actually a keyword in IFO, right? I just didn't bold it, okay? But let's say if this is the only post condition we have for this particular routine, okay, this particular query. So now we're saying that if I is larger than 0, in that case, it's going to imply result will be exactly equal to I. For example, if you say the absolute value of 3, it should give you exactly 3, right? So now I want you to think about, is this post condition over here satisfactory? Or you think it's missing something? I'll pause a little bit to see if you got any questions. So Rain is actually asking a very good question. So then, so post condition must be violatable. Yes, basically in a little bit more 1090 term, whatever you specify. Okay. While you're thinking about this exercise over here, in your 1090, you learned about tautology, right? Versus contradiction versus contingency. Okay, I think it's just relevant, so that's why I'm mentioning this, right? It's not really covered in the lecture, but I thought it might be good for your knowledge, okay? So guys, you learned about these 3 terms over here, tautology, contingency versus contradiction, okay? Okay, without testing you, let me just tell you what they are, okay? Tautology means it is something that's always true. For example, if you say 3 larger than 2, it's a tautology, right? It's always true. On the other hand, for contradiction, it's the opposite of the spectrum. So it's always false. For example, if you say 0 larger than 2, right? It's always false. It's a contradiction, okay? Contingency over here is something that might evaluate to true or you might evaluate to false. It depends. For example, if you simply say x larger than y, in this case, we are not too sure if this will be true or false because it depends on what x and y are. Okay, hopefully you can see the simple analogy here. So now, if you think about when you do precondition and postcondition, it would be very weird if your precondition, let's say postcondition, okay? Let's say here. It would be very weird if your postcondition simply is a tautology. That means the postcondition is simply true always. In that case, why do you bother to check it, right? If your postcondition is actually, on the other hand, a contradiction, that's also very weird. That means the supplier has no chance to satisfy their clients by providing some service that wouldn't trigger a postcondition violation, right? So either having a tautology or having a contradiction for your contracts is not a good idea, okay? So what we really need to get is a contingency, which means the precondition and postcondition, they should be, as Ring said, it should be violatable. It might be true sometimes when things work, or it should really be violated when things don't work. So that's the idea, okay? Okay, hopefully that answers Ring's question over there, okay? Okay, so now let's go back to this particular example over here. So now what my question is this postcondition over here, which only talks about I larger than 0, is it satisfactory? Think about a postcondition would not be satisfactory if something that goes wrong from the supplier side. However, the contracts that will constrain the supplier cannot signal any error. So that will be considered as a bad postcondition. So that's how you can define what do I really mean for the postcondition to be complete, okay? So guys, do you think this particular postcondition over here is fine, or you don't think it's fine? If you don't think, why not, basically, right? Anybody want to speak up or want to type some answer before I tell you? Okay, so priority. I'm not too sure what do you mean by priority over here. Okay, let me see from Nina over here. No, it doesn't take into account negative numbers. I agree. That's absolutely correct. Also from Nora, it's not fine. It doesn't talk about negative value. I agree. Okay, and then Chauvin, you talk about having brackets or not. That would not be the issue actually. So here, so this will be one Boolean over here. This will be just another Boolean. So just Boolean implies Boolean. So that's okay. Okay, so I think what you guys said is actually on the right track. So the problem over here is we did not talk about basically all the cases that might happen. Let me just give you one example here. Whenever you want to prove that your postcondition is not complete or good enough, what you should really do is you should give a particular wrong implementation that will satisfy all the existing postcondition. If that's the case, that means no signal will be no error will be signal. Let me give you one example here. Let's say I have this wrong implementation. Okay, so I'm gonna give a wrong implementation. Okay, so I'm gonna say if it is the case that I is less than 0 over here. Oh, let me say this. If I is strictly larger than 0, and then result is simply assigned to I. So this part is correct, okay? So as to satisfy this particular case, right? Otherwise, result is equal to, let's say, I. Or let me make it a little bit more extreme over here. How about, let's say simply just 23. Just give a magic number. I believe everybody will agree that this particular postcondition over here is simply just, this particular implementation here is simply just wrong. More specifically, it is this particular branch that's wrong. When I is actually a negative number, the absolute value will always return 23, okay? However, the question is, if we try to call the following, okay? If we say over here, okay, let's say this, okay? Let's say I'm trying to call from the client side. If I simply say absolute value over here, if I try, for example, 23, okay, let me say 10. If I say 10 over here, so I'm going to execute this particular branch. The result will simply just be 10. So now 10 larger than 0 is actually true, implies result which is 10 is equal to 10. So this is okay. That's an okay case, right? Let me talk about the not okay case with you. Let's say over here, if I got, let's say, absolute value over here, let's say minus 10. The expected result from this query should be 10. That'll be the correct one. However, let's see this. If I simply pass minus 10 over here, so that means it's going to execute this particular branch over here. So that means result is going to be assigned to 23. That's the wrong result, we agree. However, the supplier can do anything they like. However, it's really up to the contracts that is signed with the clients, which will decide whether they have done something right or wrong, right? It's almost like as long as the supplier doesn't violate the law or the contracts, whatever they do will be considered as acceptable. Okay, so now is this acceptable according to the contract? I will argue yes, because when we evaluate this particular postcondition over here, let's say this, right? I larger than 0 is it true or false? Well, I over here is actually minus 10. Minus 10 larger than 0 will give you false. And remember, false implies anything will simply just be true, right? It's a very special case for the implication. If the antecedent is already false, the whole thing will just be true. So that means this entire postcondition over here will just give you true. So no postcondition violation as far as this particular condition is concerned, right? Agree. And unfortunately, that's the only postcondition you have. You don't have anything else. So it will simply go through this, and then no postcondition violation will actually happen. So that means no contract violation. However, is it really good? Well, apparently in this case, it is not good, because we know very well that the internal implementation over here for the supplier is simply just wrong, okay? So what's the main message from this particular illustration? The main message is, okay, let me write it down over here, okay? Think about the conceptual sketch, and then got to move on to the next one, okay? Let's say I got any routine R over here, right? Can be a query, can be a command, okay? You got some parameter over here. And then over here, This will be the implementation. Let me just put the syntax a bit better over here. Remember, you start the implementation with do, okay? And then over here, you got ensure over here, okay? And for the ensure, you may get post condition number 1, post condition number 2, and post condition number 3, and etc. You can get as many post conditions as you like, okay? So now, let's think about this. When the implementation, the blue one over here, I mean, whatever the supplier does, is correct. In that case, all of these should be satisfied, okay? So that means P1, P2, and also P3, all should be satisfied, should all be satisfied, okay? That's point number 1, but that's only part of the story, okay? Number 2 is also important, which we just illustrated, okay? Number 2, let me use maybe pink here. Number 2, when the implementation is incorrect, which means there's something somewhere over here that's actually wrong, okay? But we wouldn't know because supplier can do whatever they like. It's hidden from us. Where the implementation is actually somehow incorrect, at least one of P1, P2, P3, etc. should be violated. So I would say 1 and 2 combined together should define what does it really mean for your post condition to be adequate. Okay. So number 1, simply say if you're lucky, the supplier simply does what they're supposed to do, and then all your post condition will just have to be satisfied. Okay. But number 2 is actually more fundamental. The main purpose for having a post condition, especially a complete post condition, is really to say if there's anything that goes wrong in your implementation, in that case, there should be at least one of the stated post condition over here that should be violated. If, on the other hand, all of them, when something is wrong, are still satisfied, in that case, that means your post condition is not complete enough. Okay, hopefully you get the idea. Right, so this is really important idea. I'll definitely try to revisit as many times as I can with you. Just try to pick it up, as much as possible for the first time. Let me say one more thing. So if you more or less get an idea, that's good. For the lecture series week number 2, that you're gonna start on Wednesday officially, you're gonna see exactly how you can write complete post condition, especially if the implementation is actually supposed to modify some array structure or composite structure. In that case, having the post condition being complete will be very important. So you will see a complete case study when you do the lecture series number 2 in this coming Wednesday. Okay, so that's something we can talk about maybe next week when we get to Q&A. Okay, guys, any question over here? Okay, all right. But I think for week number 1, so hopefully it's only maybe a few confusion about the terminology. So week number 1 is not that technical. So that's why I can talk about something a little bit extra just to talk about earlier with you. So you can get some early exposure. Okay, let me move on to the next one. Okay. Over here, this is just like a very quick clarification. Okay. So the question was like this. What exactly does contract really mean in the design by contract, right? When we say design by contract, apparently contract over here is very important, right? What does that really mean? Is it referring to the Boolean expression over here? This part is absolutely correct. Whenever you talk about some contract, either precondition, postcondition, or class invariant, yes, it must be a Boolean expression. A very common mistake, which I briefly mentioned in the tutorial video. For example, let's say this. If you have a postcondition over here, or it could be precondition, right? If you say across, okay, so hopefully for those of you who have already gone far enough with the tutorial video for lab 0, you would know what across really means. If you don't know, you might be a little bit behind. You want to move up faster, okay? Let's say if I say across, let's say 1 until, for example, a.count, for example, right? Is some local variable I, and now I can say all over here. Let's say li larger than 10, for example, right? For those of you who actually know about what across really means, so we know that this whole thing over here using across is using all, which means it really corresponds to the logical, the universal quantification, which is a Boolean expression. So this will be, as far as the compiler is concerned, this is actually okay. Okay, a very common mistake is for students to do this. If, let's say, they rather than doing this, let me use a different color here. Rather than doing this, if they simply say loop over here, that's also allowed, one of the allowable across construct. But if you say this, you're going to get a compile time error, but hopefully you wouldn't make that mistake. The reason is now the whole thing over here, if you use loop, it now, rather than Boolean expression, is now simply an instruction, which is only meant for implementation. Okay, so that's a very common mistake. So what you made about the observation that every counter should be Boolean expression, that's absolutely correct, okay? Okay, and then, so when there is a counter violation, it can be precondition, postcondition, or class invariant violation. The violation refers to a condition. Well, that's exactly true, because if there's a Boolean, so it can either be a true or false, right? So that's right. So this will be something I want to just talk to you very abstractly speaking, right? So think about before you move to 3311, right? Before you take this course, what you would typically do is, let's say you're trying to implement some routine, okay? Again, maybe a query, maybe a command, maybe an accessor, might be a mutator, doesn't matter, okay? Has some parameter over here. And now you might just do the do and end over here. So you only got implementation. This is what you're used to do in your 2030 or in the previous Java course. But what we really want to introduce to you is you want to have some extra layer of checks against your implementation, okay? So that means you want to always design some precondition over here to say, in order for me to execute this block of implementation, something must be true beforehand, right? Conceptually, okay? And also after the implementation is executed, so I should really put some postcondition to say, to really decide whether the implementation has done the right thing. For example, in the previous one over here, you can see, even though I have a postcondition over here, but that one there is simply not complete enough. So even though I got an incorrect implementation over here, the postcondition here will still be considered acceptable because nothing will be checked to be evaluated to false in the postcondition, right? So that's why I said if something that goes wrong, at least one of them, the postcondition should be evaluated to false, so you will get a signal as early as possible, okay? So what's really the point about writing contracts? So for now, I'll try to review this idea over and over, is really to add an extra layer of checks against your code. So whenever you execute your code, you want to make sure the precondition is satisfied beforehand, and also the postcondition, which is much more crucial, is also satisfied afterwards. And for lecture series number 2, you will see how complicated your postcondition can be using also some object copying. That's something you will learn in lecture series number 2, okay? Okay, so now that's another one over here. Okay, let's talk about this one. This one is also interesting, okay? This one is more relevant to how you will use the testing, okay? So that one, maybe just some very quick explanation, okay? So guys, to really let you get the most out of this particular question there, maybe I wouldn't mention too much about the background because it's really referring to video number 5, okay? Number 1 is referring to that. I'll just tell you what the answer is. And for those of you who maybe forgot about the details or who hasn't even got that far, you may want to review the video first before you can understand what I'm trying to say here. But I'll just give you a summary to the answer. Let me just read the question to you. In tutorial part number 5, which is about testing a particular query called isMonth with 31 days, right? It's one of the static features in the birthday class, okay? For those of you who have seen the video, you will know what I'm talking about. Okay, so now there was 2 things shown to you in the same video. One is about the assertion violation error. The other one is about the postcondition violation error. So I think the student who asked the question here, they were not sure why it should be, in one case, it should just be assertion error. But in the other case, it's the postcondition violation error. So that they were just not very clear about why it was the case. Let me just summarize quickly for you. Okay, I see some update on the chat. I'll get to you in just a moment, okay? Let me just summarize this very quickly. So first of all, let's consider the supplier side, okay, over here. So we are talking about two versions of the this particular query, okay? So this is version number 1, okay? And this is version number 2. We talk about the same query. And what's common about these two query is they have the wrong implementation. So now you can see the wrong implementation here. I simply cross out the correct implementation. I simply say result is always false, and the result is always false. Apparently that's wrong, okay? So in both versions of this query here, we got the wrong implementation. And now what we want to know is, does it really make a difference when we, in one case, we don't have any meaningful postcondition. The only postcondition we have for version number 1 is to say class. And this class here simply just make the feature static, as I mentioned in the video, right? Now, in version number 2, we actually got a very good postcondition over here. We say result if and only if this particular condition is actually true, right? So we explained this predicate already in the video, okay? So now hopefully you can see the difference between these two versions. In both versions, you got wrong implementation, but in one version there, you don't have any meaningful postcondition, which means when something that goes wrong, you wouldn't be able to catch it, right? On the other hand, in version number 2, because you got a very strong, a very suitable postcondition, when something that goes wrong over here, you will be able to blame the supplier right away, rather than the clients would know about this particular failure from their side. So what do I mean by this? That's why I got to show the client side as well. And in your tutorial video, I also created one query, one test query over there. It's called a T static query. You can refer back to your code, okay? Let me just explain very quickly, okay? Of course, in the tutorial video, I show you like a version number 1, first of all, and then I show you version number 2. So you don't really see the two versions at the same time. So now I'm just putting them together to show you, okay? Let's say over here, let's now imagine running the two versions at different timings, okay? So now let's see what this test is doing. It's doing something very simple, okay? It's simply just trying to do over here. You would say the result, which is a Boolean, is simply assigned to, we simply say birthday is month with 31 days, and then we pass January. The expected result should be true. That's what's expected, right? Apparently, calling version number 1 or calling version number 2 is going to give you the wrong result anyway, right? Because both of them are simply just going to give you false. However, why in one version there is going to give you an assertion error, but in the other version is going to give you a postcondition error? That's basically what the question was about, okay? Let's see why, okay? Let's talk about version 1 to begin with. When you call this particular query over here, first of all, it's going to check its precondition. And its precondition is simply say the month should be valid. So now it's one valid month. It is. So the precondition will be satisfied with no problem. And then it's going to execute the body of the implementation. In this case, is wrong. It will simply assign the result to be false. Okay. And then, as we said also in your lecture number 1, after this particular feature call, we have to check every postcondition. And now the only postcondition you can check would be just the class. And that one you can think about is equivalent to true, really. Nothing to check logically. Okay. So now that's why for version number 1, when you call this particular with version 1, when you call version number 1, there'll be no postcondition violation. And it again reinforces my point. Does no postcondition violation really mean it is good? Not really, right? Because you actually got the wrong implementation there. And then simply no postcondition violation doesn't really mean everything's good. It simply means your postcondition is not enough. That's what it means, okay? So now what's gonna happen is, for version number 1, when we say, and the result is simply just going to be assigned to false because it's simply going to return false. So when we say check result and, it's going to fail, okay? So for version number 1, it's going to be a check assertion error. And this is not considered as good because the clients actually, when they try to use this particular feature call and they simply try to check their result and they find that they got a check assertion error. So they have no one to blame. okay? You can only blame the supplier if it's a post-condition violation. So that's why version number 1 is actually not satisfactory, okay? So this is not satisfactory because no supplier to blame. You can only blame the supplier if it's a post-condition violation. Otherwise, if there's only a check assertion error, you don't know who to blame. No post-condition violation. No post-condition violation over here, okay? So that why version 2 is actually better. Let's see why, okay? If we talk about version number 2, it will still give you the wrong implementation. However, itself has a better contracts that's more fair to the clients, right? So now let's say we still try to execute this client's code, and then we execute this particular input with 1. And then when we actually give that, the result was still, okay, now the question is, are we ever going to reach this particular line of code to check the assertion? Okay, the answer is no, because even before we get to this point over here, as soon as this particular routine is actually executed, okay, let's see, if you imagine you put the breakpoints and walk into this particular routine call, right? Imagine you do that, right? So now if I do that, so after doing this, result has been assigned to false. We have, before we can return from the routine, we need to check for every post condition. The first one here is simply just true, no problem. But now when we check the second one over here, right? Remember the input is simply just 1, right? Just 1 over here is 1. And 1 is going to satisfy one of them. So that means the left-hand side for the equality will just be true. However, the result over here is simply the wrong implementation, which will be false. So true, if it's only a false, will give you false. So that means we're going to get this error earlier as a post-condition violation, okay? So now what I need to take a note for you will be, so for this one over here, for version number 2, it's going to be a post-condition violation. And this is considered as more satisfactory because when something goes wrong with the supplier's implementation, there should be a corresponding post-condition violation for sure. If the post-condition simply say they're happy, even though there's something wrong with the supplier's implementation, then there's something wrong with this post-condition, okay? That's something I will keep emphasizing, right? Okay, let me see a quick question there from Positive. When we violate the post-condition in violating test, when is the ensure condition really checked? At the time the function call, or okay, let's say this. The question goes like this, okay? Again, it's a little bit related to lab 0, okay? Let me just be a little bit cleaner here, okay? Yeah, we'll go until 7. We'll go as much as we can go, okay? So do put your question on the chat if I somehow missed it, okay? So let's say this. If I have, let's say T over here, let's say some command. Let me be more clear here. Let's say we have one side for the clients. The client is, let me be a little bit symbolic so it'll be easier for me to sketch. Class C, okay, and then we have a command over here, which takes, let's say it takes no argument, but there's definitely no return type. And then we got some implementation over here. And then we have something that's hidden, okay? Let's say we got ensure. And then we got some post condition over here. Let's say P1 over here. And then there will be some Boolean expression over here, just something, okay? So that's a setup for the clients. I just want to help you understand what does it really mean when you run the violation test. So now from the supplier side, and the test cases you have been written in lab number 0, they are really this, oh, you know what? I beg your pardon. I just got the terminology mixed up. This C over here is the class that's going to provide service. So it should be supplier. Okay, sorry, I just got it wrong. This is supplier. And this is clients. And let me draw a little bit more like connection to your lab number 1. Okay, for lab number 1, once you get a chance to look at that, you will see that we give you quite many starter test cases to begin with. You can think about those starter cases are the clients of the features you're going to implement. So for example, for lab number 1, you're going to implement a splay tree. You're going to implement a tree nodes. Those are the supplier classes you have to finish. In order to get some better hints about how those supplier features should be implemented, you should really look at how the client is supposed to use it. And now the best documentation for the client side is to give you test cases. Let me show you why. Let's say for the client side, you got some class. Let's say you simply say test supplier class C, okay? And then over here, let's say we want to test for post-condition violation, right? You know exactly how to create that particular extra class to actually test a post-condition violation. I'm going to omit that part for now, okay? So what I would do is I'm going to say feature over here. So it's going to be a test command, okay? And then I would say test command post-condition, right? It's going to be a test command. And then it's going to be a local variable here. So here I would just say bat C. Okay? It's going to be a bat descendant as we learned from the tutorial video. And now let's say, assuming that I created one bat version of C, okay, I will simply say bat C, just over here, right? So that one there is going to inherit the P1, the constructor, okay? And then, so over here, we're simply going to say do, and then we, of course, you're going to create this particular instance. Let's say we have done that already. So you will simply say bat C dot calling this particular command, okay? Let's say this one over here, the bat C has been set up in such a way that calling this command, the child version, the bat version, is going to trigger this particular post condition to be violated. Okay, this particular one, right? So now, exactly how this is going to be, let me just see this. So now we're going to do, let's say, also you got a make feature over here, and then you got add violation case with tag. Okay, and then over here, you're going to say P1. And then you're going to say, you know, pointed to function, you're going to say agent over here, and then it's going to be this particular one, right? Just save some writing over here, okay? So now the question was, whenever you say run workbench system, what's going to happen, okay? When you say run workbench system, it goes like this. Number 1 is going to execute this particular add violation case with tag. And then you will see that you're actually going to call this particular command, which is this particular command. So this step number 2. And for step number 2, it's going to create this particular instance over here, and then it's going to call this particular command that is going to trigger the post-condition violation. And then when we actually do that particular post-condition check, number 4, presumably we will be in the context of the child class, which is bad. In that case, this particular post-condition will be violated, and then you will be returned, conceptually, you will be returned back to this particular call over here. And then they will try to see, is this particular post-condition that's being violated, it has a tag P1. Does it match the P1 over here? If they match, so that means this, even though it's a post-condition violation, but you will be considered as a pass for the case. Otherwise, you'll be considered as a failure, okay? So that's a little bit of, the, just the detail about how things are being checked, okay? Okay, so Ovek simply said, could you go through my question there? So did you put it on the chat or on the Google Doc? If that's on the chat, I need to maybe scroll up a little bit. You message me. Okay, I'll take a look. Give me one moment. Okay, so now there's one question from Ray. Are both Q&A sessions the same content? No. So what I'm going to cover today, I'll just continue with, because I don't think I have enough time to get everything done. So you guys can still join tomorrow. So both Q&A will just be answering your questions. So maybe tomorrow will be something different. So that's for your advantage, really, because they're recorded. There's no point to repeat. So Ovek, let me look for your question there. Let's see if there's somewhere in the... Okay, I don't see you being here. Okay, that's here. Okay. For the missing case in the precondition balance less than 0 is from the previous one. Yeah, let me just mention your question very quickly, right? So Ovek is really talking about, again, let me go back to here. you're talking about this case over here, okay? Apparently there are two fixes over here, right? Again, how you actually design your contract is completely up to you, okay? So you can definitely do the precondition being less than or equal to 0, as we explained previously, or you can let the invariant to catch that. But actually, you know what, Ovek, let me, this might take a little bit of time to explain. Why don't I make a notes? And then I'll explain this maybe in the Q&A tomorrow, or maybe I'll address that. So this might take a little bit more time to set it up, okay? So here, the question really is, invariance violation. So that's basically your question, right? So I would say my quick answer is, if you simply got an invariant violation here rather than a precondition violation, it is not as satisfactory, because when you are having a invariant violation, that means you have already created an invalid object. So that wouldn't be so desirable. Rather, you should really prevent from that particular invalid object to be created by using a stronger precondition. Okay, that's basically what you want to have. But I'll try to illustrate this with a little bit more details maybe tomorrow. I just need to set it up. Okay, very good. All right. Okay, guys, let me continue with it. Okay, so I've gone through quite a bit of today. Okay, so now we got another one over here. Okay, guys, it's again the same situation. Okay, let me see how many I need to go through. Okay, one, something about the predicates, and something over here. Okay, and the exercise. Okay, not too bad. I'm almost through all the questions you put on the Google Doc. Okay, so let me spend another about 10 minutes or so. So maybe I can take use the last 10 minutes to take your question, and then we'll continue tomorrow. Okay. Okay, let's do this. Another one is also related. So this question here is actually a very good question here. So we talk about version number 4, where we actually introduced some faulty implementation. If you recall, what we did was, when we try to do the withdrawal, right? We simply say, rather than subtract, we simply say add over here. So that's the wrong implementation, okay? So now, let's just go through the question. When there is a contract violation, only one side should be blamed. It is true. But in this example, you said that it is not the case. Is it because the supplier and clients are to be blamed, or neither? Okay, I would say in this case, it's simply not very clear who to be blamed for the following reason. Okay, so let's say this. Let me just annotate this a little bit better. So you also have seen this in the lecture already. Apparently, this is the wrong implementation. If there's a wrong implementation, so that would mean there should be some postcondition violation. There should be. You can almost think this is like a principle, guiding principle for your design, not just for labs, but also later for your projects. Whenever there's any issue with the implementation, it should be caught by one of the postconditions that you design. If it is not the case, that means your postcondition is not complete. Okay, that's a principle. So now in this case, the only thing we check, if you recall the example we did in the lecture over here, the only thing we check is to check this particular invariance, right? We say that invariance simply says the balance should be strictly larger than 0. However, now let's just give you one example here, right? So now if we say we create this particular account for Jeremy, $100 initial balance. Now, if we execute this particular wrong version of the withdrawal, when you say you want to withdraw 50, what you will do is that this wrong implementation. You will simply say 100 plus 50. So what you get is you get 150. As far as the check is concerned, it's definitely going to satisfy this particular invariant over here. So that means no postcondition violation will be occurring, because there's simply no postcondition, right? So now that means when you run this particular code, no postcondition violation will occur. On the one hand, on the other hand, you can see the printout here. Used to be 100. After you withdraw 50, you actually got 150. That's definitely not acceptable, right? So even though it is not acceptable, but there's no postcondition violation occurring. So that means there's something wrong with the design for this particular code over here. Okay, so hopefully that's clear to you for those of you who asked this question here. Okay, let me just tell you again. So we'll keep mentioning. Having no culture violation is not necessarily a good thing. Not necessarily. It might be a good thing, maybe not. Just not necessarily. However, this is how you should judge. You should really define your postcondition in such a way that there should be no leaking, faulty implementation from the supplier. If the supplier can just get away from your postcondition such that they can do something crazy and won't be caught, so that means you should really review your postcondition to make it more complete, and that's something you will see in week number 2. Okay, Siobhan over here. Let's see this. Siobhan asking a question here. Let me go over that. Okay. Let me see. What would be the pre and post condition of a sorting routine? For example, bubble sort. I think it's interesting. Okay, would it be involving going through the array to see if it is sorted? In that case, wouldn't it be inefficient if the array has millions of elements? Essentially, okay, good. Okay. What you're asking was this. Let's say I got my query over here, the command or query. Let's say it's a query. Okay, that's called a bubble sort. Array, let's say, is simply an array of integer. Okay, and then I'm going to put a return type as well. That's also an array of integer. Okay, I'll just put int for now. So you were asking what should be the pre and post condition. Well, I'm not sure about if there's any precondition for bubble sort, because unlike binary search, for binary search, you mean the array must have been sorted already. So now I would say you can definitely sort an empty array. You can sort an array of size 1. You can sort an array of size 2, and etc. Right? So now, there'll be no precondition, I believe. But now for the post condition, right? You want to say the array is sorted. But how do you say the array is sorted? So that's something we would like to work out, right? Why don't I give this as an exercise for you over here? But I'll give you some idea, right? If this is my array over here, after the sorting, I know that it should be the case that, for example, let's just give you one example where it is sorted. For example, you might get 23, 24, 24, 46, 89, and 89, right? So apparently that could be what, let's say we sort in a non-descending order, okay? Let's say in this case, index 1, index 2, 3, 4, and 5, and 6, okay? All of these, this array apparently is sorted because you can, let's say this is A. So we know that A1 is actually less than or equal to A2, right? You can see this part here is actually sorted. And also, let's just do one more. And also A2 is less than or equal to A3 over here. So that one there is also sorted. Okay, so you gotta really do this to cover all the indices. Okay, how should you specify this? I'll leave as an exercise for you. If you want to know the answer, work it out and then maybe discuss with me if you struggle. Okay, I'll let you work out this particular predicate here. But based on what you will learn in the lecture number 2, series number 2 for week 2, this one should be rather straightforward. But think about it. Okay, so now Shafin got another question actually. So what if the array size is very big? So let's say what if a.count over here is maybe simply equal to 1 million. Okay. In that case, if you got 1 million elements there, if you want to check to see whether it's sorted or not, it's going to be a linear algorithm to check. It's going to be a linear, right? You're going to go through so many elements in the array. You're correct. It's not going to be efficient. However, this is okay. Okay. There's something implicit about this course over here. let me write down the principle over here, and then I may have to give you some extra demo tomorrow. Okay, contracts are for guiding your implementation. Okay, let me just say this is point number one. It's only for guiding only. Okay. Number two, contracts need not be efficient. Bear with me. I'm going to get to the final point in a moment. They don't have to be efficient. They may be very inefficient. That's okay, because sometimes you might even need nested across loop to actually do your contract. It may be the case. Okay. Number three, your implementation should be efficient, right? And let me say the final points. Final points, once you are sure everything is working. Everything, when I say everything is working, I'll try to give you one concrete example tomorrow in the Q&A. I'll try to give you that. But let's say once you're pretty sure, let's say whenever all the test cases I'm trying to run to simulate a scenario, all of them are passing, right? But that means no counter violation is really occurring, even for the normal cases, and also counter violation really occur when there's some wrong implementation, etc. So everything is really working. Okay. Once you're pretty sure everything is working, you can turn off the contracts. So this is actually quite an important point over here. You can turn off the contracts. You don't really have to do it for this particular course, but that's something you want to know what you can do with the contracts. So in iFlow Studio, for those of you who might look at the pre-study documents before, there is one option for you to so-called finalize. When you believe your project is actually working pretty well, so everything is working according to its precondition and postcondition, in that case, before you ship your software products, you can simply finalize it and then turn off the contract. So you'll be just efficient implementation. Okay, I will try to give you one example over here, maybe tomorrow. Okay, but here I'll just talk about principles since you ask. Okay. Okay, before I get to this particular logic over here, let me get there in a moment. Let me see if there's any more question there. Okay, we got about 10 minutes. Okay, Caleb, let's see, for the across S Boolean expression for universal, okay. An empty array returns true, but it should be, okay, so let's say this. Okay, assuming that many of you have seen a cross already, assuming that, okay. Let's say I have a array of integer, let's say. For those of you who took 2030 with me previously, if you can recall, when I talk about recursion, right? So I said, how can we define recursively the following routine? Let's say I want to make sure let's say whether the is all positive, for example, of an array. Given an array, I want to know recursively if all the elements in the array is actually positive, right? So we talk about base case. So the base case would be if I simply call is all positive on an empty array. So now the question is, what should be this value over here? Should it be true or false? Guys, anyone? First of all, let's guess this answer here, and then I will continue. It's actually related, okay? So the question is, if I want to define this particular query, it's all positive. It's going to take one array, okay? It's all positive. If I simply give the base case, which is empty array, should it return true or false? Okay, let me see the message over there. Okay, very good. So Ovek, that's exactly correct, and Nora, that's also correct. Okay, it should be true. Okay, for those of you who are not really sure, okay, let me just talk about this particular one that's related to your this course. Let's say if I say create a dot make empty, right? We know how to use array. So now if I say across, let me move the across a little bit lower, okay? If I say across A is, let's say every member in the array is I, let's say, all, universal quantification. A larger than 0, okay? And I'm just using 2 across. A less than or equal to 0. I think that's kind of interesting, okay? So now let me just tell you how you should read it. This is the first across, okay? This is the second across. And for your information, one is about A is larger than 0. The other one is A is less than or equal to 0, right? Okay. So now tell me something. What should be the result of this particular conjunction? Number 1, it should be true. Number 2, it should be false. Okay, guys, I think it's really worth talking about this, okay? I see some answer over there, okay, but I want to see your thought, okay? It could be a quiz question later, maybe not for this week. It could be later. Okay, I'm glad to see answer from both sides. That's okay. Okay, so just try to see what the answer is. Okay, so now for those of you who might think it is false, it could be because you see A larger than 0 here, and also A less than or equal to 0 here. When you learn in 1090, when you say like a P and not P, right? It should be equivalent to false. That might be part of your reasoning, okay? But it's not the case over here because we actually got the across, the universal quantification as a context over here, okay? So now, the way to understand this is this. This particular universal quantification is simply just true. The second universal quantification over here will also be true, okay? And let me try to remind you a little bit what you learned in 1090. So when you say for every x, okay, which is a member of the empty set, okay, it is the case some predicate of x. This is always equivalent to true. So this is one of the theorems or axiom you learned from 1090, right, about universal quantification, which means if I simply got an empty collection over here, I want to argue some property about every member in X. The result for the universal quantification will always be true. Okay, that's something you learn. So now, why is that? The very brief justification for this is because you cannot find any violation of Px. Thinking this way, in order for me to prove that this universal quantification is false, I just need to find a witness. And the witness is going to make P of X false. If I can find such witness, I can prove that this universal quantification is actually false, right? But can I find a witness in the empty collection? The answer is I cannot. So that means whatever property you mentioned over here, you never can find any witness in the empty collection for violation. So it should always be true. That might be how you understand from the previous logic course, right? But if not, I'm explaining to you. So now over here, so that's why when you argue this particular property P over here, it doesn't really matter because A over here is simply just empty. So it will just be true. And over here, you're just arguing another opposite of the property here. It doesn't matter because you just cannot find any violation case from the empty array. So it will still be true. So overall, it's going to be true. Okay, I hope that answered your question there. Okay, right? That's quite an important thing to know because we are linking programming with logic, right? For example, when you learn about 2030, when we think about this particular recursive call, recursive routine, we had to think about the base case. But what should be the base case for empty array? So that's why if you get a base case wrong, let's say false rather than true, of course, you wouldn't be correct, right? Okay, so now we only got about 3 minutes left. How about this? I would suggest I only got 1 or 2 slides to show. I will do that from tomorrow. Okay, so tomorrow this will still be a Q&A session there. We will talk about something. We'll just continue with the topic, right? Let me just go over the chat quickly. So if you can stay a little bit longer, I'll go maybe a few minutes over. I'll just go over your question there. Okay, so from Tempeh. So let's say from the supplier side, somehow the precondition, postcondition, and class invariant are the same line of code. If the user violates one of them, which one pops up? Okay, that's kind of interesting. Okay. The question was like this. Let's say we got class C. Invariance over here, and then let's say we simply say false is allowed, which means as soon as you create an object at the runtime for this particular class, you will be violated right away, okay? And then let's try another one. Let's say we have a routine over here. Let's say the command. Require over here, let's say it's simply just false. And also you have some implementation. And then here I would say ensure that's also false. Yeah, basically we are saying that if it happens that the precondition will evaluate to false, postcondition might evaluate to false, and also invariant might evaluate to false, which one will be violated first, okay? It depends on how you use it, okay? I can think of at least 2 cases, okay? So let's say here, if I say creates right? That's how we declare a constructor, okay? Let's say case number 1, okay? If I say this over here, so now on the client side, if I declare, let's say I declare a variable, let's say object C of type C, okay? So now if I say create over here, OC.make. Oh, actually, you know what? I didn't mean to say make. I meant to say command. So command can also be used as a constructor, okay? OC.command. So the question goes like this. So now you can see that we actually got the precondition over here being false, postcondition here being false, also invariant over here being false. If I try to make this particular call, what kind of violation would I get? Am I going to get a precondition violation, class invariant violation, or postcondition violation? Anyone for this one here? Just for this particular call, let's see. Okay, Tempeh, you can answer too. I see something called, I see invariant, I see also precondition, okay? So precondition is actually correct. Why? So what Kevin said about invariant is not the case because, so now in order to really create the object over here, in order to call this particular command, the very first thing you check would be its precondition, always, okay? So now the precondition is already false, so that means you're gonna get a precondition violation. Okay, so I think that Tempeh that maybe answer your question. So if you really got, let's say the false, false, and false over here, and then you're simply trying to call the feature, of course, you're gonna violate the precondition first, because in order to call a particular feature, you have to make sure its precondition is satisfied. And the invariant will only be checked after the implementation has been done, but you wouldn't get to that point, okay? Okay, let me just go over quickly. Okay. Okay, I think so they were asking something specifically about the is equal for their code. I would say send an email to me. Maybe I can answer this, maybe offline, okay? Okay, I think that's pretty much through. Okay, so I think it's about time. So we'll continue tomorrow for the second Q&A session there. I do have maybe just 1 or 2 more slides to show you that I prepared. And then remember the exercises I gave to you today, the extra ones. Take a look at them, and then we can discuss them tomorrow. Now, of course, if you've got more questions there, we can take them. Today is mainly just to digest the question I put on the Google Doc. Okay.
Hi, Professor.
Hi.
Hi. I just I wanted. So you say previously like it really depends on like the case that violates the environment or like the pre or post condition. Could you illustrate another example that may violate that environment instead of the
condition? Another one. Okay. Mm-hmm. I would say because Tempe, your question was: is it possible to set up an example such that I can violate the invariant instead? I would say, given that the precondition is really false over here, so that would be always the first one to check when you call the routine. So there's no way around. Let's say this, for example. If I try to get rid of this particular false just temporarily, okay? Let's say over here, imagine that this is gone. Okay, I'll just say gone. Okay, let's say this is completely gone. And the require is simply just true. And now when I try to call this particular command over here, am I going to get a post-condition violation or invariant violation? Let me be more explicit. According to the state diagram I draw to you at the end of your lecture slides, what should be the case? Should it be a post-condition violation or should it be an invariant violation? That's the question. Anybody?
It should be invariant because like each time the environment check before the post condition. I remember that like that.
Are you sure? Okay, let's double check. Yeah.
The diagram.
Let's check very quickly. So guys, what I'm talking about is this particular diagram here. Let's say just for the account example, it would be very similar. So let's say this. After you call this particular implementation over here, let's say after that, you see the first one you check is the post condition, not invariance. It's only after the post condition check over here, and then you'll go to a state that's not necessarily safe yet. It will only be a safe green state after you have checked the class invariant. So you should read, conceptually, you can think about you will check the post condition for that particular routine first, and then you'll check the class invariance.
Oh, okay.
Okay. I would say don't worry too much about exactly this order over here, either post condition first or invariant first. I would say as long as you know, every time when you actually call your particular command or query, the precondition should be checked first. That's for sure. Okay. I think that's the main message here. Okay. All right, guys. Any more questions? Are we okay? All right. Yeah. Okay. I will try to maybe speak to the Lausanne people to see why you guys cannot really send a public message. I don't know why, really. Okay. You can see I showed in the beginning to you. I did try to allow that in the Zoom setup. Okay. Anyway, so I'm gonna end over here. Thank you for coming. So I will see you again tomorrow if you are interested. I'm gonna talk about maybe different stuff. Okay. I'll make the recording available later. Okay. I'll see you later.